Okay, so this problem says let R be a ring with identity and let M be a non-zero R module. Show that M is irreducible if and only if every non-zero element of M generates M. So first, let's recall the definition of what it means for an R module M to be irreducible. We call that by definition an R module M is irreducible if it's not the zero module and its only submodules are the zero module in itself. So the only submodules of M are 0 and M. Okay, so we have two directions to show. So suppose first that M is irreducible. Well, let A be a non-zero, arbitrary non-zero element of M. We want to show that it generates M, so uh, um, also we know that this A exists because M is a non-zero R module. Uh, but even if it didn't, the statement would still hold vacuously. Okay, so um, we know that RA is a submodule of M, right? That's easy to check with the submodule criterion. Um, but since A is non-zero and 1 acting on A, which is A, is an element of RA, we have that RA is a non-zero sub, not the zero submodule. That's a non-zero submodule of M. So since the only submodules, thus since the only submodules of M are 0 and M, we must have RA equals M. So A generates M. Okay, that's one direction. Now let's do the other direction. So conversely, suppose that every non-zero element of M generates M, and we want to show that M is irreducible. Well, so okay, what does this mean? So for each A and M with A not zero, we have RA equals M. Okay, so to show M is irreducible, we have to show that it's not the zero module and that the only submodules are 0 and M. But remember, part of the problem, the hypothesis of the problem was that M is a non-zero R module. So by hypothesis, M is non-zero, so we must show that the only submodules of M are 0 and M. So, okay, let's suppose for contradiction that those aren't the only submodules of M. So suppose for contradiction that there exists a submodule, call it N of M, such that 0 uh, N is not the zero submodule and it's not M, so it's strictly in between. Okay, well, N is not the zero submodule, so let A be a non-zero element of N, which is a subset of M. Okay, well, since A is a non-zero element of M, remember, we're supposing that every non-zero element of M generates M. So RA equals M. But also RA is a subset of N since N is a submodule. Right, the uh, definition of a submodule implies that you have to absorb products from R. So A is an element of N, so any element of R times acting on A will still be an element of N, right? Okay, but so RA is equal to M and RA is a subset of N. So that means that M is a subset of N, which is a contradiction because we supposed that N was a strict subset of M. And that completes this problem.